Hey, everybody. We have a different kind of warm up today. It's kind of interesting. Yesterday, I was telling you that we have the diamonds every day, but this is something special. Okay, it's algebra. Okay, it's all about algebra. We are going to learn how to solve basic algebraic expressions. Okay, and it's one of those things that um, that my kids, my students, usually are kind of amazed at if they take it slow. If you take my advice and do the things I ask you to do, you will be amazed at how easy it is, how you are able to solve algebraic expressions. And you will walk tall and proud if you do this. Now, trust me, okay? I know some of you right now, no, you don't understand, Mr. Dan. I'm not good at math yet. Add that word, okay? And you can do this, okay? Whoops, sorry about that. Let's zoom back out again. Trying to just adjust it. So get a piece of paper, or even better yet, get your composition book out, okay? This is something that you want to have written in your composition book, all of these steps, so you know how to follow it later, okay? So first off, algebra, algebraic expressions, solving it, okay? There's a Japanese saying, you've heard me say this before, but just to refresh your memory, slow is smooth. Okay, if you take things slow, then things aren't too bumpy. You kind of go smooth, right? But smooth is fast. Smooth, things just like slide nice and smooth. You go fast, right? So think about putting these two together. Slow is smooth and smooth is fast. Okay, what do I mean by that? I mean, if you trust me and listen to me and try it my way, because you're gonna be tempted. Like that little kid wanted that cookie. You're gonna be tempted as soon as it came out of the oven and mom had to go upstairs. You're gonna be tempted to grab that. I don't want you to get burned. Okay. If you trust me and take this slow and follow these steps, we're going to practice with easy problems. But when they get hard, you're going to have these steps down and you'll just take it one step at a time and it'll be easy. Okay. So remember this. Okay. Slow is smooth, smooth is fast. Please trust me. Okay. I know and want what's best for you. Okay. I want math to be easy. I want you to say, oh, algebra is easy. I thought it was going to be hard. Right. I want you to trust me. Okay. So, uh, the equal sign in any equation um, is like a balance, right? You guys remember seesaws? They don't have seesaws as much anymore. I think there's one over the middle at the the Boys and Girls Club park. It's just not your old typical one, but it's I think one you could stand on or something. But old seesaw, it's like an old balance, right? I want you to think of an equal sign being like a balance. And whatever is on one side is in perfect balance with what's on the other. Okay? So, what is on this side? A 4 plus 3. What is on the other side? 7. And 4 plus 3 is in perfect balance with that 7, right? So, 4 plus 3 equals 7. 4 plus 3 is on this side, 7 is on that side. Now, if things are in perfect balance, and then you go and you do something to one side, like in this case, I add a 5 to the 4 plus 3, it would be out of balance unless I do the same thing to the other side. If 4 plus 3 equals 7, that was in perfect balance, and I added 5 to this side, but then I also added 5 to this side, think about it. It's still going to be in balance, right? Right? I go back to being in balance. Now, if I had 4 plus 3 plus 5, right, and 7 plus 5 on this side, and then I subtracted 2, if I subtracted 2 to this side, it would be out of balance unless I did the same exact thing to the other side. Then it stays in balance. You can do anything to one side as long as you do the same exact thing to the other side. It'll stay in balance, okay? So when you see these algebraic expressions, I want you to always remember that you can do anything to one side as long as you do the same exact thing to the other, and I want you to solve it one step at a time, and I want you to show all your work. And remember, if you take it slow and easy, okay, it will be easy. Okay, if you take it slow, show every step, it will end up being easy. Okay, because we will start with some easier problems, and you might be tempted to just solve it in your head. Okay, but we want to break down exactly everything we're doing into steps. So when the numbers get hard, the steps just come to you because you practice those steps and you just do the step one step at a time. And then the problem, even though the numbers are hard, the problem is easy because you're just doing a series of steps that you've sort of built into a habit. Okay. All right. So let's do this first one. Okay. Now, feel free to pause and copy this down in your composition book, okay? Then you go to solve this. Now, x minus 3.2 equals 14.1. Now, what does this equal sign mean? It means that everything is in perfect balance. This x minus 3.2 is in balance. It has the same value as that 14.1. Now, when we solve an equation, what is our goal? What are you trying to do here? You're trying to find out what that is. What is x, right? I want to find out what is x. And that's how you solve the equation. Now, do you know what is means in math? Is means equal. So when you get done, you're going to say x equals something, right? That's my goal down here, to have x equals something at the bottom, right? Then I've solved the equation. So think to yourself, I want the x all the way by itself here. Okay, and right now I have other things. Okay, ¿cómo se dice isla en inglés? What did you say? I said, how do you say island in English, right? Isla in Spanish is island. We want the x on an island all by itself. So who do I have to kick off the island? Not just 3.2. I have to kick off a minus 3.2. So here's what you're always going to do. You're going to rewrite and give yourself a little bit more space. What's there now? And how do I get rid of a minus 3.2? I do what's called the opposite. Okay, that's how we would say it. Now, if you want to sound real sophisticated, you would say, I do the inverse operation. Now, remember what operations are in math? Adding is an operation, right? Subtraction is an operation. Multiplying is an operation. Division is an operation. Parentheses are actually an operation, right? That's why we have the order of operations. Exponents are an operation, right? All sorts of different operations. But there are opposite operations. What's the opposite of plus 7? Hopefully you're thinking minus 7, right? Right? What's the opposite of minus 4? Plus 4. What's the opposite of minus 7? Plus 7. What's the opposite of times 3? Divided by 3. What's the opposite of divided by 2? Times 2. Okay? So we want to know what the opposite of minus 3.2 is. Do you know what it is? It's plus 3.2. So if I add 3.2 to this, it's like doing the opposite. And a minus 3.2 and a plus 3.2, think about that. You owe 3.2 and you have 3.2, put it together. Poof. They cancel each other out. However, that would get the x all by itself, huh? But I had an equation. It was in perfect balance. And I just added 3.2 to this side. Is that going to be in balance anymore? No. Unless what? I can do anything to one side as long as I do the same exact thing to the other side. Okay? The same exact thing. So if I want to do the inverse operation or the opposite of minus 3.2 with a plus 3.2, that's okay if I do plus 3.2 on this side. Okay? Now, again, these things, what's going to happen to those when I put them together? A minus 3.2 and a plus 3.2? Poof, they cancel each other out. All that's left is an x over here, which is what I wanted. I wanted it isolated. Isolated. I wanted to isolate the variable. That's what we call this. And look at that word isolate. Isolate means you go put it by himself, right? ISLA, ISL. Yeah, it's like putting it on an island by itself. So you want to learn this term, isolate the variable. That's our goal, right? Because that gets us an answer. If x is by itself, I have an answer. X equals something, okay? So they cancel each other out. Now on this side, what do I have? I have 14.1 plus 3.2. Well, what is that? Well, let's figure it out. Remember when you add decimals, you line up, you stack them and line them up, and it comes straight down. Okay, 17.3. X equals 17.3. Boom. I have solved this algebraic equation. Okay, now, if you're smart, you're going to take everything slow. And when you get done, you're going to say, wait, if x equals 17.3, can't I substitute 17.3 for x? I mean, if it equals the same thing, right? Yes, you can. And if you do that, and you write 17.3 in for x minus 3.2, you have an equation that will allow you to check your answer. If I did this correctly and x actually equals 17.3, then when I substitute, then this sentence will be true. 17.3 minus 3.2 should equal 14.1. Well, let's check it. When you subtract decimals, you line them up, stack them, one on top of another, and then you do the work. 3 minus 2 is 1. 17 minus 13. Boom. It works. You guys are learning how to solve algebraic equations. Okay? Now, here's some more I want you to try. Please, though, promise me, pinky promise, okay, that you will follow these steps. And remember, slow is smooth, smooth is fast. Take your time. Do every step. Go overboard with showing your steps and showing all your work, because then you will make those steps a habit. Okay? And if you make those steps a habit, life will get easy. Life will get easy. All right, so you're going to try this one. B plus 2.2 equals 18.1. You're going to try M minus 6.3 equals 24.8. You're going to try N plus 4 and 1/2 equals 11. Aha, fractions. All right, you try these three. I will release the answers in the stream at about 9:30, and you could check your answers. Okay? All right, good luck, everybody.